You have a handful of 3D printers, you've got OctoPrint set up, either on a single Raspberry Pi or multiples, and the printers are somewhat the same model or all identical in your farm. It would be nice to share Gcode files once in a while. Hello everyone, Chris here. The idea for this video came straight from the comments from one of my previous videos. And these are things that I actually like to do. I like to tweak the software and the firmware to make it do things maybe it wasn't intended to do, but it might help somebody else out. And this user is running OctoPrint and multiple 3D printers. Now they're probably printers that are pretty much the same model. They have to be either identical or close, or you wouldn't be able to run the same Gcode file on all of them, because not every Gcode is going to work. But it is possible to do this. And remember, OctoPrint was always intended to be a one-for-one scenario. You have one Raspberry Pi, one OctoPrint instance, and one printer. But we have done a lot of videos recently about multiple instances on one Raspberry Pi where you can control multiple printers. And there's a lot of users out there that have multiple printers and multiple Pis. And it is possible to share this file in all these ways, but I'm going to show you how to get it all done. Just kind of a fun video for me, honestly. Again, I like to do this kind of thing, and hopefully it helps somebody out. So let's get into it. I'll show you how to get all this file sharing stuff done. And just to get us rolling, here's what we're using today. I've got a Raspberry Pi 4 and a Raspberry Pi 3. Now, if you're using multiple Pis and you want to do the sharing between both of these, I would use the faster or the more powerful one as your server, then use these as clients. You'll see more of that. Just focus on the highest powered one to do a lot of this. Maybe you had a couple of zeros. Let them grab the file from the more powerful one. Now, it's not going to matter a whole lot. It's pretty light to run one of these shares off of one of these. Just keep that in mind if you're having performance issues, because they are pulling that file. Also, you are not isolated to Raspberry Pis. I've shown this many times. You can run OctoPrint on pretty much anything that can run Python, and you're going to be able to achieve these same results. And the stuff that we're getting ready to do is just standard Linux command stuff. Not a lot of 3D printing users are probably going to know a lot about Linux, so that's where I try to fill the gap. But again, it doesn't have to be on a Raspberry Pi. You can run this on pretty much anything nowadays. We've done it on TV boxes, Windows machines, all sorts of different installs. So a lot of this is going to work exactly the same if it's Linux based. So let's jump in and see the files that we're going to share. First, we're going to focus on the multi-install after we've ran Paul's script. So here we have multiple OctoPrint instances. These are all running on the same Pi. You can kind of fact check me up here, the same IP. We've got the 1.20 address up here. It's running on 5001. We just called it printer 1. I just made this for this video. And then printer 2 over here, same IP, different port. Running multiple OctoPrint instances, multiple printers on one Pi. The easiest way by far to do this is using Paul's script. I have a video on just how to do this. It's very easy to do. All of that information will be in the description below. Here's Paul's GitHub. This is for OctoPrint deploy. Again, a very easy way to get up and running on one Pi using multiple printers. So this one is focused on the multi-install, one Raspberry Pi. And we're focused on Gcode file sharing. So you've sliced your file, you've got your Gcode ready to put on your printer, ready to run it from OctoPrint, ready to go, but you would like to share it with multiples. Now remember, we're all on the same Pi, so there's a lot less steps here, but they are isolated. So let's just go ahead and grab a Gcode and we'll upload it. So I've just got my generic box shape here. We'll hit upload. We've uploaded. We're on our first instance. Remember, this is printer 1. Our Gcode file's here, ready to print. Now, what makes the decision for this where it actually stores those Gcode files? Well, it's all inside OctoPrint, but you can alter that through the Settings tab. So we'll go up here to the wrench, go down to Folders. This is the location for your uploads. This is just a directory that's in your home folder. The default user is Pi. .printer1 has a folder and .printer2 has a folder, so it keeps them separate. So we've got our box shape here. If we go to our second instance, we have no files down here. We can refresh the list. It's still not pulling anything because it's a different directory. Just to make sure, we'll refresh the browser. we have fully verified it doesn't pull that file in. And to double down, we'll jump into PuTTY and take a look SSH. We're in the home directory here. You can see the tilde, but we'll do ls-als. You can see printer 1 and printer 2. If we do an ls on .printer1, we have our uploads folder. So we'll take a look inside the uploads folder, and there's our Gcode file. But you saw up here we have one for printer 2. Those OctoPrint instances are separated by these directories. So let's just change to printer 2, take a look at the uploads folder. There's nothing in there. So both of these Gcodes cannot be printed on these printers. They're not shared. You can only print it on one because it only exists there. And when you have multiple installs, these are all owned by the Pi user. They all have the same permissions. So it's very easy just to share these via the Settings tab. So back to OctoPrint 1. You can do this multiple ways, but we'll go to Settings. You've seen Folders. We've got printer 1 here. It has Upload. All we have to do is change the other instances, whether you have 2, 4, 8, whatever they might be. We'll go to printer 2. Go to Settings, go to Folders. It says printer 2. We'll just change that to printer 1. We can test it. The path is valid. We'll save. On printer 2, we'll restart OctoPrint. And when it comes back up, it knows that it's pulling out of that printer 1 upload folder. And it'll be populated right down here. So printer 2 has the file. Printer 1 has the file. So in this configuration, if you were to upload to either one of these instances, it's going to pull from the same folder. So you'll have it on both. Just for an example, let's go to printer 2 instance. Let's upload our test1 Gcode. It's been uploaded. Go back to printer 1. We'll refresh it. There's test1, and vice versa. Upload test2 Gcode. There it is. Back to printer 2. Test2 Gcode. So you can utilize any of these Gcodes from any of the printers you have on your multi-instance install. So that's super easy, right? You have multiple installs running on one Raspberry Pi. All you have to do is update the folder to whichever one you'd like to share. You might want to create a new one rather than using the default folder, but it's all going to work the same. Just make sure the permissions are the same so that all the instances can get to it. Also, if you have other Gcodes in some of those other folders, you won't be able to see them any longer, so you might want to copy those over, just in case. But it's very easy to do. Just change it up in settings and you're good to go. But what if your printers are running on separate Raspberry Pis? That's a little trickier, but not all that hard to get set up. That's what we're going to be focused on now. Now on to the really fun stuff. So we have our printer 1, printer 2, Pi 4 running over here. We've got multiple instances. That doesn't really matter. But now we want to be able to share those files with multiple instances and multiple Pis. Over here on the left, we have our single OctoPrint instance running on a Raspberry Pi 3B. It's running over the network, different IPs, this one over on 183, these two over on 20. So we want to be able to share those files back and forth. So we're going to jump into SSH. So again, here with our PuTTY tool, we've got both of our Pis pulled up. Over here on the right is our multi-install, Pi multi, and then our single install over here on the left. The first thing you want to do, no matter if it's the Pi install with Raspberry Pi OS or a Linux install like it is on the multi-Pi, you want to run sudo apt update on both and then follow it with an upgrade. Remember, on the default, Raspberry is the password for your sudo to go into root. Once the update is complete, we'll just pull that back up, switch update to upgrade. Again, running it on both. That's just going to get us up to date with the newest versions. Okay, so we're up to date on both Pis. Remember, on the right, we have a Raspberry Pi 4, multiple instances. On the left, we have a single Pi install. We are going to use what's called Samba. We're going to make a Samba server so that we can share our Gcode files with the instances on the Pi and with all the other Pis that you might have. You can use a share, you can mount it up, and share your files. There's a couple of steps to do this. You have to get a few things just right, but that's why we're walking through it. We're mostly going to be focused on the server side. The Pi with the multiple instances, again, that's a Pi 4. It's got more horsepower, so we're going to use it as our server. Everything else will be a client. So to get us started, the first thing we're going to do is install Samba. I'm going to have a Word doc that you can just copy and paste all these commands from, but we're going to do sudo apt-get install Samba. It's a pretty quick install. It should only take a minute. Samba has been installed. And for my Linux friends out there, I know there's a lot of different ways to share files. This method that I'm going to show you, I think it's the easiest way for a new user to understand how this works using Samba. And on the other side, we're actually going to use CIFS. That's not a traditional Unix way of sharing files. I just think it's the easiest way to show other users how to do this. So hang in there with me. Next, we're going to make a directory that we can share. I want to use a specific directory, not one that exists, so we don't overwrite anything. And I can just show you how to make it and the permissions you're going to need, because with Linux, permissions are everything. If you're having an issue, it's more than likely something wrong with the permissions. So do it exactly how I do it. So if we just do an ls-l here, that's going to let us look at our home directory. Remember, we have the tilde. Pi is the user that I'm focused on. You might use a different user, but Pi is probably the most common in between OctoPrint and other things we do with 3D printers on Raspberry Pi. I'm going to use the Pi user for this whole tutorial, and you'll see more on file permissions. The Pi is the user and the group for all the permissions, so they stay consistent. We even force that user so we can use it from Windows. Again, you're going to run into permissions issues if you don't do something like this, or you're not familiar with how all of this works. So we're going to stay in the Pi user directory for this whole install. If you do a pwd, that shows you where you are. We're in home Pi, the Pi user's home directory. So from here, we're going to do a make dir for make directory, and we're just going to make one called Gcode _share. You can call it whatever you want. This is again just for this video. Remember though, the folder name, if we do an ls-l again, we have Gcode _share. The share name and the folder name or directory name aren't necessarily going to be the same. It'll make more sense in a second. Now we're going to change the permissions on that Gcode share. Remember, this directory is owned by Pi, user and group. We didn't use sudo to create it, or sudo if you'd like to call it that. That would make it root. We want it to stay the Pi user so that we can force that user and everyone will have the same permissions as we use it with different machines. But we're going to go ahead and do a chmod, change modify, and we're going to enter 777. This gives read, write, and execute to all of them basically, meaning user, group, and other. Anybody can write to this, read from it, or execute. So just enter the directory we created, Gcode share. If you do that ls-l again, you can see it's green now. Putty does that, but all of this over here means it's wide open. Not the most secure configuration, but I'm assuming that a lot of people that are using this with their 3D printer have this on their home network. I'm just trying to make it as easy as possible to share files with multiple machines, and opening it up with all 7s is going to make that happen. Feel free to lock it down further if you need to, if you know what you're doing here in Linux. So we have our permissions set, we've got the directory we'd like to share, now we need to configure Samba. So we're going to do sudo nano, which is the text editor, /etc /samba /smb.conf for the Samba configuration. So there really isn't much you need to change in this configurations. We just need to add a share. Now, depending on the distribution you're using, the version of Samba, it might be different. But with Raspberry Pi OS and the current version of OctoPrint, all these changes I'm going to make are the only ones that you need to make. Now, if you're using Nano, if you do an alt /, that will take you all the way to the bottom of the file, which is where we want to add the share. We don't want to edit anything else. In brackets, just add your share name, whatever you would like to call the share. Remember, this is not the directory name we just made. This is the share name. So we're just going to call it Gcode share, but no underscore. That's important to remember. Remember, that's the share name. And then under that, we're going to add all of the options for the share to configure it. And I'll try to explain all of these. But the first one, I just like to add a comment. So comment equals whatever you would like to call this. Just a note in here so that you know it's your share. So I usually just put something in like my test Gcode share. This is so I can go to other platforms and confirm with this tag that it is the share I think it is. Next line will be path equals. That's the path to your share. You saw we just did that make directory. It is in /home/pi, and it is called Gcode_share. That's the directory name, not the share name. So we're good there. Now, most of the rest of this is all based on permissions. I'm opening this wide up so that you can get to it from anywhere inside your network and be able to share these files. So you don't have any collisions with permissions problems. So the next thing we're going to do is browsable equals yes. That just says you can browse it as pretty much any user. It's just you can see what's in there. The next one is kind of the important one. We do guest space OK equals yes. This pretty much means that any user, including guests, if you don't even have a username, can get in there and use this share. This is the biggest stumble. Like if you had something like public yes, it doesn't mean the same thing as guest OK. So again, this is making it so that everybody can get to it. Guest OK equals yes. Read only. We just want to enter this and confirm. No, it is not a read-only share. We want to be able to use it. We're going to create space mask equals and then permissions. Again, 0777, that's wide open. Everyone has access. The create mask is for Windows. So when Windows tries to access this share, it will have the same permissions that Unix does currently, all 7s. We're also going to do directory space mask equals the same thing, 0777. This is at the directory level. So when you're creating it from Windows, it will have all the same permissions as we currently do. All 7s wide open. Now, from the Unix side, different Linux Unix hosts, we want to do force create mode equals 0777. So something coming in that's using the share will also impose the same permissions, leaving it wide open. And then same for Windows, but now on the Unix side, force directory mode. And on this one, we're going to do equals 02777. I believe that is called the sticky bit. I would have to go in deep with permissions on how that works, but a lot of these leave it where the last user left it, or the new user, or you can't, the user that doesn't own it can't erase it, all that good stuff. Just trust me, 02777 is where you want this one. So that any other Unix host is going to treat it the same way. And then finally, we're going to force a user. Force space user equals pi. So any file that gets interacted with, read, written, all that good stuff, is going to use the same user pi. If you have a different user, change this here, but we want to keep that consistent so we don't have conflicts. So I get to another pi where I have another username, it won't have access like the pi user would. So either create the pi user or just keep that consistent across all of your platforms. And that's it. The share is configured. I'll go through, make sure my syntax is correct, all my spelling is good, and when I think everything is correct in Nano, Control X, Y, enter to save. Now the Samba share is ready to go. So I just recommend you do a reboot. Now every time the Pi comes up, Samba will start and your share will be available. Now we're going to go to the Windows side after this thing reboots and make sure we can access it. The reboot is complete. We're logged back in. We already know the IP, but you could always do a hostname -I. There's your IP. And then now that the share is available, we can just go to Windows. I just click on the Start key and then start typing. / that IP, 92.168.1.20. If you hit enter, there's your nobody share, which is the default share, and then Gcode share, the one we created. Remember the share name. And it has the caption underneath it, the comment that we left, my test Gcode share, so you know that that's the share we created. If you click on it, you don't have any access problems, you're good here. And just go ahead and test copying a file in there. So I'll copy just that same Gcode we tested before, paste it in. We can write to it, we're good. So you can get to that share from your new Samba server from Windows. But it would be really handy if all of our OctoPrint instances shared it. So now let's go to the single Pi and configure the share on that side. We just have to mount it up. So here's our single install, our Pi 3. It's just running an OctoPrint image. The first thing you want to do if you have distributions of Linux, just make sure that CIFS utilities are installed. Again, I'll have a doc where you can copy and paste this, but you just want to do sudo apt-get install cifs-utils. Most of the time they're already there, but we'll make sure they're there. So that's good. Now we need to create the directory that we want our share. So you still have to create the directory as an object, even though it's going after a share that lives somewhere else, we still have to have a placeholder for it. So just like we did on the server side, we're going to do it on the client side. So make dir /home/pi/Gcode_share. It doesn't have to be the same name. You can name it whatever you want, but I would keep it consistent if I were you. Remember, we're using the same user, Pi, across all these instances to keep it consistent and make life a lot easier. So the directory is there. Make sure that we open that directory up. We want a sudo chmod 777 to give it all access to everyone, /home/pi/Gcode share. So it has all the correct permissions, ls-l. There's our share, it's wide open. Now we can just manually mount it. It's kind of a long-winded command, but do sudo mount, and then where the share lives, / the IP of the Samba server, 192.168.1.20. You just saw that when we went to it in Windows. And then the share name, not the directory name, Gcode share, not the underscore one. This is what's configured in the Samba configuration. That can be somewhat confusing. Now, where would you like to mount it? Well, we just created a directory to mount it in. We created that in /home/pi, and it's called Gcode_share. And then you need some options because of all this permission stuff. Even though we don't need a password, we still need to enter that option, or it's going to ask you for the password. So we're going to do -o and password equals, and then you don't need anything after it. This is just to keep it from asking for the password as soon as we hit enter. So we'll hit enter. It's Gcode share, no S, so typo, hit enter, and now it's mounted. There's several things you can do to check that mount, but the easiest way to know that you're going to have your files, we're already in the home directory, so from here you can do an ls to list that Gcode share. And you can see the file that we put in it from Windows. So that's a good sign. If you'd like to check what's mounted on your Raspberry Pi, you can just do a mount, and that'll list everything that's mounted. Here's the mount that we just created. So now you can access anything in that share from this alternate Pi. Now, the only other thing that you need to be worried about is that if you reboot, that mount won't be consistent. You'd have to mount it every time. The easiest way to get around that is to add your mount to FS tab. So we'll do that real quick. We'll do sudo nano /etc/FS tab. And we'll just go to the bottom here and create our new mount point. So it's basically the same command. You don't have to do the mount and all that good stuff, but you have to tell it where it is. //192.168.1.20. That's the Samba server location where the share is, and then the share name, Gcode share. Then where would you like to mount it on this machine? We said /home/pi /Gcode _share. Then what type of mount is it? It's a CIFS. CIFS. Then we need some options to keep it consistent with the usernames, all that good stuff. For the most part in FS tab, you can just take defaults. So the first option will be defaults. All your options after that will be comma separated. So comma, and we're going to do username equals pi, because we want it to always be pi. And then we want to give it the UID and the GID of the username. More than likely, if you have one user on a configuration, especially on a Raspberry Pi or a OctoPrint image like this, the user ID and GID are going to be 1000. So you can do comma UID equals 1000, and then comma GID equals 1000. This just ensures that it's always using the same ones, no matter where it's being written to, read from, all that good stuff. It's just going to make life easier. Now, what if you don't know your UID and GID? They're not 1000. So this is going to work. We're good in FS tab. Control X, Y, enter to save. You could always do cat /etc/PASSWD, the password file. This has got all the users, system users, root, all that good stuff, and it gives you all their information. But you can find that Pi user. It's right here. And you can see it's got UID and GID of 1000. Most of the time, 1000 is going to work for anything that you're going to do, but it's always worth checking. Now from here, you can go ahead and reboot to make sure that that share is going to be mounted. You can also test writing some things if you'd like. So I'm going to go ahead and reboot, sudo reboot. Once the reboot's complete, you can go ahead and do that mount command again. Make sure that that Samba mount is there, which it is. So it came back after reboot. And then just do a test to write something to it. I'm just going to list ls / the root file system. So what's in it? And I'm going to do 2 greater than signs. That will append text, the ls command text, to a file. And we're going to send it to our share, which is at home /pi /Gcode share. And we'll just write it to a test.txt file. So that wrote it to our share. And let's just read it back. So let's take a look at what's in that file. So cat /home /pi. I'm doing the long command, so I show you how to do this. Gcode share test.txt. What's in it? This is the output of the ls command for root. You can verify that if you'd like, ls /. There you go. So you're able to write to the share. If you really want extra points, go back to the Samba side, the server side on our Pi 4. Here's our multi-instance. And let's just do an ls /home /pi Gcode share. There's our test text. So we're writing and reading back and forth. We have shared this folder. Now all we have to do, go to OctoPrint and make sure it's using that shared folder. So this is our Raspberry Pi 3. We don't have any Gcode uploaded to it yet, which is good because we're getting ready to switch what directory it uses. We're going to go to Settings, Folders. This top one here, it defaults to Uploads. We are now in Home Pi Gcode _share. That's our shared location. Hit test. It's there. Hit save. And then go ahead and let OctoPrint restart. After the restart's complete, we see our list down here. It's only going to list things that are .gcode. But while we're here, let's go ahead and test it. We'll do an upload, and we'll just grab a random Gcode file. Remember, this is pushing files over the network, so if it's large, it might be a little slower than you expect. But we're actually pushing that through this Pi to the other one. And then there's our Gcode file on our single instance. Now let's jump over to the Pi 4 where the Samba server is, because we're pulling Gcode successfully from our share now. Here's our printer 1 and 2. We'll go back to settings, folders, and now we want to start pulling from that Gcode share. Gcode_share. Test it. We're good here. We'll let this instance restart OctoPrint, and then let's go to the second instance, again on this same Pi. Settings, folders, Gcode_share. Restart this instance. We'll let it restart. Let's go back to printer 1. You can see we have our single and our other Gcode that we pulled in from Windows. We'll upload one of its own. We'll just call it this printer 1 Gcode. We're good there. Go to printer 2. We got printer 1, all of our other Gcodes. Let's upload a printer 2. We can write to it. Go back to printer 1. I know we're all over the place. Hit refresh. There's the printer 2 Gcode. And then finally, let's go back to the single instance. Right here, we'll refresh, and there's all the Gcodes that are in that share. We could even verify it in Windows. We still have that share open. There's all of the files that we've uploaded from OctoPrint. Now you can share them in multiple locations, upload them to OctoPrint, ready to print, all that good stuff. If you were to happen to need to do this, you have wide open access to that Samba share server via CIFS. So there it is, a relatively easy way to set up file sharing in between multiple instances on the same Pi and any other Raspberry Pi you might have via the network. And it's not just for Raspberry Pi. Anything you're running Linux on that has access to Samba and CIFS, this is going to work. So you can share those files pretty much on any type of Linux platform. And I realize that this is a little nerd-tastic for most folks, but if you were to happen to need to do this and you're a 3D printing person, not a server Linux type person, this might be extremely helpful. And again, I'll have all the commands in the description below, so you can just copy and paste it and get on with all your 3D prints, sharing all those Gcode files. And you could probably do this with your Clipper install fairly easily. It runs Linux just like any other machine does, and you can use Samba and CIFS, so why not? So give it a try. Hopefully you found this helpful. That is it for today, and I'll see you really soon on the next one.